All right, so let's look at this problem. So at this point in the class, we have like three major tools that we can apply. One is we can look at zero force members if there are any. We've got method of joints, which you could apply our two equations of equilibrium at each joint. And then we can cut sections and look at method of sections. There's a lot of different ways to solve the problem. Let's do this to start. Are there any zero force situations? Do you see any joints where there's two elements connected by a pin? Looks like A is one of them, and C would be another. Now, C has a force applied, so that rules it out, but A does not. So that means right off the bat, this element and this element are zero by inspection. Now, if I look at another loading case and there's a load applied at A, that's not true. But for this case, there's zero. So what I like to do is just literally write the word zero force, and I'll say F at AB equals F at AE, and they equal zero. So what I think I'm going to do, because I think it'll be an advantage later on, and plus it's a good first step, is find the reactions of the truss. So I'm going to come over here and I'll draw a quick little free body diagram of the whole structure. I'm not really that concerned about the internal makeup. I'll just kind of draw it to scale. So I have the force applied here at F, and that's 100 kips. And then I'm going to assume at D, which is a roller, that I have a single reaction. I'll call it dy. And then E is a pin. So I'll have two reactions. I'll call that EY. This is a little harder to see. I'll put it there and I'll say EX. Also some dimensions. That was 30 feet, 20 feet, and 20 feet. So I want to find those reactions first. Who did I leave off with? Miss Miranda, are you up?
I guess.
So where's a good place to sum moments?
E.
I'm sorry?
E.
E. I like E. So we're going to sum moments at E. Why is it E a good place? Well, two of our unknowns pass through E. We should be able to write one equation for dy. So let's sum moments about E and make sure it's in equilibrium. So, Mr. Santana, what is the sum of the moments about E for dy? Positive or negative?
Can you say that again, please? Positive.
Correct, sorry, yeah. So dy creates positive moment, and what's its moment arm about E?
It's
20
20 feet away.
feet, right? So Mr. Sanchez, what about the 100 kip force? What kind of moment does it create about E? Positive or negative?
Negative.
I'm sorry?
Negative.
Negative, yeah. And what's its moment arm?
30.
Correct. Everybody see that? So we should find dy. Looks like dy is 150. Does that sound reasonable?
Yes.
Anybody get that? And it came out to be positive, so 150 kips. Mr. Patel, what do we want to do next? Sum forces in the X or the Y? That sounds reasonable to me. So we will sum forces in the Y direction. We'll assume up is positive. Why don't you go ahead and sum forces in the Y direction for me? What do we have?
Positive 150 plus E sub y.
Well, look at the free body diagram. So I've got what?
E sub y plus E sub y.
That's right. So I've got EY plus DY. Anything else? There's no applied forces in the Y direction, right? And of course, if I put my value for D right in there, or DY I should say, what's that make EY equal to? Negative 150. What's next?
Acceleration.
You got the hard one. So if we sum forces in the x direction, I'll assume to the right is positive. What's the sum of the forces in the x direction?
EX plus 100.
Yeah, so EX is to the right, and so is the 100. So what is EX?
Negative 1.
Negative 100. So that's not so bad to get started. One thing about this course is we're going to be finding reactions like every day for the rest of the semester. That's always pretty much our first step. So this will get very, very routine, I hope. Okay, so now what do? Now the strategy comes in. Let's just talk for a second. Can I use method of joints at, let's go alphabetically, at B? Mr. Cantu says yes. Why? How many unknowns at B? 1, 2, 3. How many equations can I write at a joint? 2. You don't get a moment at a joint, remember? So I can write 2 joint equations at B, but it'll be in how many unknowns? 3. Is that a good place to start? Negative. No. What about C? How many unknowns at C? 2. B, C, and C, D. So that's a possibility. How about D? No. It's got 1, 2, 3 bar forces. What about E? How many unknowns at E? 2. 1, 2. The other thing about E is look at them. One of them is all Y, and one of them is all X. So of the 3 joint possibilities, path of least resistance, E, maybe followed by C. So let's do that as a way to start. So let's do a joint at E. Is this the only way to go? No. At this point, writing joint equations, E and C are the only places you can go and be successful. But it's not the only way to go. I could cut a section here, right, and do method of sections and find these 3 forces. There's a lot of different ways to approach it. But let's just stick with a straightforward right now. So looking at E, there's my free body diagram at E. I'm going to put my forces on. So I found EY was minus 150. I assumed up, so really it's 150 down. EX I assumed to the right, and it's negative, so I've got my 100 going this way. So those are my 2 forces at E, or my 2 reactions at E. Now I'm going to come along and assume a tension force in DE and a tension force in BE. This is about the best situation you can hope for in this particular. Who did I leave off on? Mr. Cantu, did I get to you? Yes, I did. Mr. Lexa, what do you want to do? You want to sum forces in the X or the Y? You want to do Y first? In case you're wondering, it doesn't really matter, because if you sum forces in the Y direction, which is what we're going to do, Ms. Smith, sum forces in the Y direction for me. I'm sorry, say it again.
Negative 150.
Yeah.
Plus B.
That's right. So we got the force in BE up minus 150. Not a hard one to solve, so the force in BE is 150. So is BE tension or compression? Tension. Mr. White, what do we do next?
Sum of the forces in the X direction?
That sounds reasonable. Could we have done that first?
Yes.
We could have. In this scenario, yes. So what is the sum of the forces in the X direction?
100 kids.
Are you giving me the answer or are you giving me the equation?
I'm giving you the equation.
What's the equation?
The force in DE.
Uh-huh, that's positive, right?
Yes.
And then what else?
Minus 100.
There you go. So the force in DE is 100 kips. Compression or tension? Tension. So I'll put a little wiggle on there. I've got those two. So I only need 3 to go. So let's revise our strategy. We can still go to C, right? We mentioned that beforehand. Can I now go to B? Sure. I have 3 bars interacting there, but now I know one of them, so I have 2 unknowns, so I could do that. Could I go to D? Sure. I think it's still a safer bet to go to C, because you notice that when I do a joint at C, I'm not including any of my other previous calculations. It's going to be a standalone. So if you've made an error so far, it won't affect your results at C. So let's do that. So I'm going to go to joint C. There's my free body. I have an applied force of 100 kips. And then I have a tension force from CD and a tension force from BC. And since we're there, what's the slope of that line? What's the slope of this line? Looks like the run is 40 over a rise of 30. How convenient. Another 3, 4, 5 triangle. So that would be a 3 height to a 4 horizontal. Mr. Zacher, what do you want to do first? We can sum forces in the X or we can sum forces in the Y. Let's say we sum forces in the Y. Is that a good first start? Well, both our forces have Y components. Probably not a good start. So that leaves us X. So let's start with X first. So summing forces in the X direction, making sure we have equilibrium. So sum the forces in the X direction for me.
So it'd be 4/5 BC, FBC.
Is that positive or negative?
That is negative.
So 4/5 FBC to the left. What else?
Plus 100.
Plus 100 kips to the right. So it looks like the force in BC is positive, what is that, 125? Is that right?
Yes.
So BC is in tension. So we've got BC. So now we can sum forces in the Y direction. Did we finish everybody? Oh, Mr. Coleman, you're up. Sum forces in the Y direction. We'll assume up is positive. So what do you got? What's the Y component of BC?
3 over 5.
Is it acting up or down?
Down.
Okay, so that's negative 3/5 FBC. What else is in the y direction?
Minus FCD.
Right. And we know BC, right? BC's right there. I can stick it right in there. It looks like the force for CD is going to be negative. Is that right? I think so. So let's see, what is that? 75? So let's tick that guy off. So who's left? B, D. How's the best way to get that one? Yeah, if I look at B, there's a lot of geometry to deal with in there. Two of my forces have X and Y components. It's not hard, but if you go down to D, only one of them has an X and Y component. That's the one you're looking for. So you get some forces in the X and get it, or some forces in the Y and get it, whichever one you want to do. I've run out of space here, so I'm going to have to flip my page over. And we'll do a joint at D. So there's D. So what do I have? I've got the force in DE. I've got the force in CD. Both of those I already know. And this is the guy I don't know. The force in BD. Oh, what's my reaction at D? It was up 150. So that means I've got this acting up. What is the slope of this guy right here? It looks like I go over 20 and I go up 15. So it's another 3, 4, 5. Say again?
How convenient.
Yeah, it is very convenient, isn't it? Now, just to relate that, if you go back and look, we've already found FED, right? We know that one. And we've already found CD. So I'll just circle those to let you know I know both of those. So really, whether you're some forces in the X or some forces in the Y, it doesn't matter. You're going to have to include a previous result, one or the other. So we're back to the front again. Mr. Heyman, you're up. What do you want to do?
Y.
What'd you say?
Y.
Y? Okay. So let's do that. We'll sum forces in the Y direction. So do that for me.
FBD times 3 over 4. Or 3 over 5. Sorry.
That's right. So 3/5 FBD up, right? What else is going in the Y direction?
Plus FCD
FCD
plus 150.
plus 150. So maybe on reflection here, maybe I would have thought about maybe going in X direction. What's the advantage of that? That's one less force to have to deal with. And I did have to compute that too, so you could have made an error from the very beginning. But this method is ripe for propagation of error. It's not self-correcting, right? So if you make a mistake early on, it just pours through. Oh, that's that water thing again. It just flows. That's water too. Tumbles. It tumbles through all your other equations. That's a gymnastics kind of tumbling. But we're going to stick with this one. So if you solve for BD, what do you get? What was CD equal to? Let me flip back over here. I calculated CD to be negative 75. So you'd plug negative 75 in here, that gives me 75. 75's 3. 120 again? 125?
What?
Negative 125?
I got.
What'd you get?
See, I did it with some of the forces in the X,
And what'd you get?
and I got. Oh, I did it wrong. I got 1/6.
We'll do it.
Oh wait, no. Yeah, no, I did it wrong. My ratio is wrong.
So what? This is what's the answer? Negative 125. Now, you could sum forces in the x direction and see if it's still in equilibrium with the values that you have. So there's a check. But at this point, that's good enough for me. So lots of work there. Is this a problem that's acceptable on the exam? Probably not. We've been working on it for 21 minutes. All right, the exam is an hour long and you have 4 problems to do, so that's an average of 15 minutes a problem. I figure if I can't do it in 15 minutes, I shouldn't require you to do it in 15 minutes. So this might not be appropriate for the exam, but it's extremely appropriate for homework. Any other questions?